Hello, I'm Matt Gren. I'm head of business at Scalac, and today on my session I have Vladimir. Could you introduce yourself?
Hi, I'm Vladimir Pavkin. I'm a Scala engineer at Scala C. I have like more than 5 years of experience and a lot of interesting projects behind my back. And also I love functional programming.
Yeah, that's a really good opening because actually today we have a very broad topic, which is functional programming in business, right? So, it's kind of exotic, right? It's like, I don't know, bricks and company. It doesn't really suit well, but actually it suits. So I know that you are having a lot of experience with functional programming, so you had many occasions to see how it can help businesses in building better software. So could you tell us as a kind of people who are more business oriented rather than technical, how functional programming is helping the businesses nowadays?
Yeah, that's a very good point. And like several years ago, you could really say it is like exotic and like nobody does it for business. People are just doing it for fun. But these days, it's actually not true. Like there are a lot of big businesses I know that are doing functional programming at scale and like having success with it. Like the first thing I want to say here is that it's important to mention that what I'm gonna be talking about is like strictly typed and statically typed functional programming, because there are dynamically typed functional languages, and I had some experience with those in my early days, and they are like it is much harder to get value for business in such languages. So it's like things I'm gonna talking about today are about like strictly about like strictly statically typed functional languages. So yeah.
Just one small pause here,
Okay.
because still I'm after engineering, right? So I know a bit what is the difference between strictly typed and dynamically typed, but just in the essence, right? It's like you can get a lot of you can spot a lot of errors during compile time when you
Yeah.
have strictly typed programming
Right.
languages.
Right.
In
Right.
dynamic dynamic type programming languages, some of these errors won't gonna occur during compile because the compile is actually during the execution of the
Yeah.
system.
Right. Yeah, you're right.
And that's mainly the reason why we wanted to make it clear that we are now talking about functional programming benefits. But when, as an engineer, you are using the strictly typed languages, it's just important for other people to understand. But we don't go too deeply into that. But it's important to understand that many of issues in functional programming can occur during compile time, and you can discover them if you use strictly typed languages, right? So that's
So
good.
yeah. So basically, so we are on pause. Like this is not.
Yeah, we can continue. We can continue. We don't have to
Yeah, I
explain.
mean, yeah. So I just have have to add that has to do with like compiler doing a lot of work for you, like in catching errors, and if you don't have this help, like most of the benefits of functional programming, they go away. So this is like compiler gets a lot of job done for you, like for free. Right. So what are the benefits of functional programming for businesses that I've seen from my experience in several companies? So the first thing is that in general, when you're using functional languages, your code is much more concise. It's much easier to read and reason about. So if you compare, for example, like Haskell or Scala to Java, like your functional code would be much more dense, and you would have much more information, much more meaning in much less lines of code. And this is kind of important because with Java, for example, there's a lot of like boilerplate, like the syntax is very verbose, and you would like basically have to read a lot of lines of code to like get what understand what code is doing, right? And about the reasoning, so functional languages, at least some, like most of them, allow, and functional approaches, they allow for local reasoning. So most of the time when you're reading some piece of code, you don't have to think about some other like global variable or some like static mutable field that can affect how this code is executed. Usually your functions are pure, and that means that like to understand a piece of code, you just need to read that piece of code and you don't have to know about anything else. So it like provides much easier like understanding of what code is doing. Like and that in essence you can like connect it to some business value where you have like new members on board, for example, joining the team, and they are much they have a much easier time just like joining the project and like starting to produce some value. So continuing from here, like there's like these two features lead to lead to your team having much less bugs and spend much less time finding those, because again, this like local reasoning, it's it just makes your code like easier to to understand what it does, and like there are no like external things that affect how this code runs. So like taking a like traditional object-oriented programming with a lot of mutable variables, right? Some global state. You can like your small piece of code can behave like differently depending on like 3 or 4 other places in your project, right? And this is really hard to track, hard to debug, if you're doing functional programming, there is no such thing. Like piece of code always does what it says, and like nothing else will affect that. So like to kind of prove that, I don't know, like I think for the last like several years, I've hardly ever used a debugger to fix my code. Yeah, from now from time to time, I like had to insert some println statements just to see what's going on, but that is extremely rare, and most of the time it's either the compiler like checks, like finds my error before I even deploy my code, or I just like quickly, like it doesn't behave as I want, I just have a quick look and see what's wrong, because like there is not a lot to consider except for the code itself, right? So yeah, on top of that, there is another feature that is kind of long-term advantage, which is composability of functional code. And so like what that means is that when you develop your components, some services or some logic, right? It is, if it's done in a functional way, it's usually very composable, which means like if you want to get some functionality by using several blocks together, you get it almost for free. It's really easy to compose things. And with traditional style programs, depending on what approaches you take to like dependency injection and other stuff, it might not be that simple to do. So what this gives you is long term, you get much shorter time to market, because like your new features, if they like piggyback on something you already have, they're much easier to develop comparing to like traditional approaches, right? And probably the last but not least point, which became really important in the recent like 5 to 10 years, in the recent decade, is and probably this is the biggest reason why functional programming became so popular recently, is the parallel computation and the concurrent programming, right? So because of the like default, the basic approaches that functional programming takes, like immutability, like not having nulls, and like strictly typed programming, parallel computation becomes much easier. Like it's almost like you almost get it for free again, because there is, when you have some mutable state, shared mutable state, you probably know about like all these synchronization primitives that you might need to work with that. Functional programming and its use of immutability and effect systems, lazy effect systems, it just makes it much more simple. And yeah, so if you have some kind of like Spark cluster, or like some, I don't know, some complex computation workloads, parallel workloads, functional programming is like a much better choice than traditional paradigms. So yeah, these are the benefits. Maybe you have some questions at this point.
Well, it sounds like, you know, a holy grail for everyone, right? So that you should definitely implement your next system using functional programming language, of course, strongly typed. So, however, that's not really the reality, right? The reality is a bit different. Most of the systems nowadays are built with object-oriented programming languages, and well, of course, I know a bit about why this is the way it is, right? I actually started my career with object-oriented programming during my studies and then in my career. So knowing all of these benefits, right? So that you have, in the end of the day, you have less code, less bugs, code open for parallel computation. So everything what we need for now, because today, because it's in the current world, that the performance of the CPUs are not increasing in the amount of gigahertz, but in amount of cores. So basically, that's sweet spot. But we still see, you know, huge popularity of languages that are not really supporting or are supporting in a very narrow way functional programming. So it seems like the business still is not, when they put on a scale and they try to weight both things, the end result is not in favor of functional programming. And from my observation, the main reason is that companies simply have easier access to talent that is on the market, who knows object-oriented programming languages. So, so that's one of the things, that the business, in the end of the day, builds system not with the technology in mind, but with the team in mind that can deliver the product, right? So, so looking from that perspective, I think that's one of the cornerstones and one of the most important ones. I will probably touch it a bit more in the next part of the call, but looking from that perspective, so that you have a team, right, that probably knows a bit object-oriented programming well, it's quite experienced with object-oriented approach. So what are the ways or so patterns or ways how these teams can actually start building next things in functional programming way? You know, when I was building systems, we have MVC, we had RESTful APIs, all that stuff, and how it's in the nowadays with functional programming, how these guys who are, you know, object-oriented could at least try to get into the new world that can help them in the end, right?
Yeah, right. So first of all, that's true, right? Like most of the talent, most of the like workforce in the industry are still like using like traditional approaches, and this is some kind of inertia, I guess, from the times where OOP was the only like holy grail of software development. A lot of people learned that, and it's like it's not easy to change, right? These things are really like not one day shift, like, right? But the thing is that for the last like decade, functional programming was consistently gaining market share, consistently gaining popularity, and I think this, like, if it continues this way, functional programming has like a really nice future ahead. So, and I've seen several teams like either moving entirely into functional programming or like partially, like just trying it out. So the two main patterns that I've experienced in my career of like people starting to use functional programming, where like the first case is when there is like a person in the company with like a technical person with a lot of experience, with domain knowledge that the government has a lot of trust into, right? The person proved that he or she can deliver product on time, like basically can deliver business value like the business wants. And then there is a new project that business wants to start, and they basically put this person in charge, like okay, you can take whatever you want. If you want functional programming, whatever, like we know you can deliver value, just do it. So this person maybe gets a team, gets to hire like 1 or 2 people, and yeah, this like I went through this myself. I wasn't the person in charge. That was early in my days. I was a person on a team like this, and this works really well. So if that person is really looking to deliver business value and also like a really skillful technical person, then it's not a big problem to like learn and deliver at the same time, right? Because this person probably not have a lot of production experience with functional programming, but because they have a lot of this like trust from the company's government and they have a lot of passion to this direction, they can do this. And like as I said, I've gone through a couple of such like successful stories of this kind. The second like pattern is also what I've observed myself is when a big company has a lot of code already. It's like again, like the first company, like in the first case, the company also had a lot of code, and they just decided to make a separate new service with a functional programming. Mm-hmm. The second approach is when the whole company decides to pivot. So either technical leadership like decides that functional programming is for some reason cool already, and it's ready to be used in production, or technical leadership changes, for example. I saw like I worked in a company that decided at one point to shift from old approaches to functional programming. So what that means? It means that most new services are developed using functional programming, and some of the old services are refactored or rewritten using functional programming. Of course, it's nearly impossible to rewrite all the legacy code, right? And there has to be people on the team that would support that like old code. But all of the new beginnings, all of the like direction, all of the development of the company is geared towards functional programming. Yeah, and that also works quite well. So that company is still like they are really huge, like talent hunters. They like hire a lot of functional developers, and like it works for them. So yeah, it's these are like the two most common ways, and in both cases, it would really be beneficial if there is some kind of technical person that is experienced in functional programming and that can like help your teams avoid some common pitfalls or some like incorrect directions at first. But as I said, it's possible even without such person. It's just it would be a huge advantage because your team would have to shift their worldview, shift their paradigm, shift how they think about code, and like this is not an easy change to do.
Okay, I get it. So I think it's something that I also can confirm with our clients. We join them either in a state when there is a new module to be built with Scala, or we are a part of a huge team that is taking efforts in migrating to Scala. So these are the two things that I see in common with what you said. When we go into that direction for a moment still, so okay, imagine that we have that team that can go into the Scala direction or functional programming direction, because Scala is of course one of the languages that is strongly typed in the functional programming area. So we focus on Scala because we have Scala in our heart. But in the end of the day, Scala is not the only language. And of course, when this team starts to implement things, they can use some patterns, some design patterns or design approach that probably are even known to the object-oriented programming engineers. Could you just put more light on that? So imagine we have the team, we have a confirmation from the board that they can do a new project in a new approach, or even they can rewrite the whole system gradually, of course, having some migration plan in place and responsible person who takes in charge, who is in charge in conducting this whole migration. And so what kind of, you know, advices you have to these teams, like they should kind of patterns or design approach they should take into building a new system in a wise way in functional language?
Yeah, right. So if the team is like doesn't have a like functional programming ninja, right? Somebody who is like really experienced. So if it's like this kind of project is new for the team, so I would advise to go in really small steps. The good thing about functional programming is like that the most simple, the most like easy to grasp concepts are bring the most value to the table, probably. So you can just start with using pure functions, using immutable values, and just avoid having nulls and like throwing exceptions. These are like 4 really simple rules that you can adhere to, and you'll get a lot of value. You'll get a lot less bugs. You'll get local reasoning, and so on. So these are like if a team doesn't have any experience with functional programming at all, I would start with these. I wouldn't go like full blown, like I don't know, some Cats effect or Zio, or like 100% functional programming stuff, like stack. I would just go with these simple concepts in the language that you probably use, so that you don't have to like learn a whole new language. You know, it's all a trade-off, right? With your business, like how fast they want the service to be delivered, and so on. But like in general, this would be a good approach, so that your team has an easier time to like switch the like how their brain works about the code. So these simple concepts are really good way to start. And then on top of that, you can build like add more complex stuff later, like some category theory and monads, like some effect systems with these lazy I/O runtimes, and so on. So yeah, that's the approach I would take for a non-experienced team to start.
Okay, and if you are experienced team and you know, I don't know, CQRS or domain-driven design, all that kind of magical buzzwords, I actually heard about them and implemented some of them even in object-oriented projects. So can they be applied in functional programming, or maybe they are actually better for that? Could you just put light on that when we have a stronger team, you know, that, you know?
Yeah, sure. Yeah, that's a great point, a great question, and a great point, because you're right. DDD and CQRS and event sourcing, all of these like approaches, all of these technologies are not only kind of doable in functional programming. Most of the patterns they use inside are inherently like functional. They fit much better to functional languages, to functional paradigm, than to OOP. So if you look at DDD, like tactical patterns, a lot of them like are really functional in nature. And like Eric Evans, like it's how many years it was ago, like 20 years ago, when he wrote his book, he was already proposing a lot of like immutability in your programs. So these are not new things. And right, so for a more experienced team, I would definitely consider these kind of architectures in their design. It of course depends on the problem that they're planning to solve, but with regards to like functional programming stack, there are a lot of really nice technologies people can choose these days, like Cats effect, or like Zio, or like Haskell if you want to go like full blown FP. Like Rust is a really good language that emerged recently and has a lot of functional programming features. Like also like this new language Kotlin, like relatively new. It also has some features that are like favor functional programming, that like encourage functional approaches, right? So there is a lot of, again, like a lot of different levels you can take it into, but there's definitely everything you might need uh, for any kind of level that you want to do it. So like if you want to have like 100% FP and like there is Haskell. If you want to be a little bit flexible, there is like Scala, there is Rust. So yeah, you definitely have a lot of tools at your disposal these days.
Yeah, actually, this is a really interesting point because you have, of course, let's go from the direction of Java, right? So Java is object-oriented. Of course, it brings some more and more flavor for functional programmers. And then you have Kotlin that, as far as my other interviewers provided feedback on, it's a Java without boilerplate. So it can give you still a lot of value as an object-oriented programmer. It can give you some value as a functional programmer, but if you really want to go into functional programming on JVM, so you are still in Java virtual machine world, because everything in your company is built with Java and so on, then probably if you want to benefit with all of these business benefits we mentioned in the beginning, right? So smaller code, less error prone, more scalable, and with a bunch of great frameworks to do that, then Scala is the choice. And if you want to switch from JVM to any other system language like Rust, because Rust is actually a system language, and you have Haskell, which is also not on virtual machine like Java, but natively compiled like Rust, which makes it more performant from the perspective of footprint on the machine, right? Because Java virtual machine usually takes several hundreds of megabytes of operating memory to work, but you have GraalVM, right? That is
Right.
around the corner, that can help you with reducing the footprint of the virtual machine quite significantly. So from that perspective, depending what are the competencies of your team, right? If your team is coming from object-oriented world, but it's not having a lot of background in functional programming, there are no strong members that are experienced in functional programming, and probably going with the path you mentioned, that you don't have to switch to different language. You just keep the object-oriented language, but you avoid certain things, as you mentioned earlier, can help you already, and can change your mindset, and you will write differently the code, but it still resides in the same language. Then if you want to go a bit extra mile, if you are a Java developer, then you go into Kotlin, but actually it doesn't give you the whole power of functional programming. Then you have Scala, and that's why we are existing as a company, that we are helping companies to write functional programs, functional systems on Scala, because this is the best language for JVM systems in functional programming. But of course we have Rust, Haskell, and all other languages. Clojure is also on JVM, right? But
yes.
What is the difference between Clojure and Scala? Do you know?
The Clojure is dynamically typed, as far as I know, and this is like a really big downside. So
yeah, that's what I thought, but I didn't want to shoot because you might know better. That's what when you were opening the whole conversation about it, was like, when you are dealing with strictly typed language, a lot of errors can be found during compile time. And if the functional language is dynamic, it can bring you more problems. And Clojure has this kind of notion, and therefore, compared to Scala, even from the very basic principles, can have this disadvantage. That's why.
Yeah, right. I would think a lot before taking Clojure, writing a new project in Clojure. Yeah.
Of course, people are picking it because they have a strong team who loves Clojure, and they are experienced, so they are not afraid of doing it. but it's great that you said how company can actually transform, how business can transform existing system into functional programming approach, not sacrificing everything in one day, right? Because it's not about killing your business, throwing all your system that you spent millions of dollars on in object-oriented way, and say, okay, we are bad, we are doomed, we have to now write everything in functional programming way. Probably that would be the wrong way to go. But if you have someone experienced, you can be more aggressive with transformation. If you have less experienced team, you can in functional programming, then you can go with more modest approach.
Yeah, right.
Go step by step into full functional programming way. So. But actually, we all know about that, right? So people around the globe, they all know about functional programming, right? When I was an engineer, and it was 10 years ago, I was even, playing with functional programming. So it's not really a new thing. And of course, there is a talent pool that is having the object-oriented background, and that's one of the reasons why people still write code in object-oriented way. But there is probably other reason why people are still not, picking functional programming languages at the first step, right? So when I was analyzing this a bit, it seems to me it is a bit dangerous zone that we are entering now, but it seems to me that we have communities, right? We have communities in engineering world, and these communities are strong. So there are strong communities around Java, there are strong communities around Scala, around Haskell, and then they all have their reasons why they keep their community around this language, right? Because they just find a lot of reasons why you should choose Java. Maybe there is better library, maybe there is the same thing you can do in Java that you can do in Scala, so why to switch to Scala, right? So all of these kind of argues can occur, right? From your perspective, when you as a functional programmer, right? Do you think that the communities can unite, or you think that they will go in still in that kind of parallel threads and they can't join together? What is your take on that?
Yeah, it's like hard to predict like any kind of how the relationship between the communities will go in future. This is really like hard to say, because it also depends a lot on like what is mainstream, what market share each architecture, each paradigm has, like which kind I don't know, like how popular one is over another, and so on. So about communities, I can say that functional programming has long been like an elite club where people know a lot of this complex vocabulary, this category theory. They just like really smart, and just it was really hard to kind of join this club, because you would have to learn a lot. You would have to like also sound smart. If like these people would have to like kind of accept you, yeah. So this attitude still exists in some parts of the community, but due to like recent rise in popularity of functional programming, and like because it became more practical, and a lot of problems are solved much better with functional programming these days, because like earlier functional programming had a lot of problems. Now these problems are gone, and this is probably another reason why people not using functional, not starting new projects in functional programming, because they're scared of the things that like really already changed. So back to my point, a lot of happened recently in the last decade that completely kind of destroys that eliteness of functional programming. Yes, there are still people that are like consider themselves like wizards in a high tower that like don't let anybody like some simple people around, but yeah, a lot happened. So functional programming becomes much more approachable, and people, and it's intentional, right? A lot of people want to make it so that people can start to use it without a lot of like theoretical knowledge, without a lot of like pre-existing skills. And like languages like Rust, for example, Rust is very tries to be very simple, very approachable. They don't, so they have a lot of functional programming kind of idioms, like patterns inside, but they don't use like this complex vocabulary. They have a really good documentation, like so that people can get it on board easily. Also, this new Zio library by John DeGoes in Scala, which also like explicit intention of this library is to be really simple, to avoid all of this jargon, FP jargon, so that people can start doing functional programming, get all of its benefits without this like without need to join this elite club of like people who know category theory or stuff like that. So I think that this trend will continue. The community is going to develop throughout like following years, and I think the functional programming, because of this, will gain like more and more of the market share of the software development market share. And yeah, who knows, maybe in 5 to 10 years functional programming will become mainstream because of that. Because like you can see, like not only like new technology uses functional programming, there's like existing technology, as you said, Java picks up a lot of functional features. And yeah, I think this trend is only going to continue. So so with regard to the like traditional communities, I don't know, they also have some kind of eliteness to them, and so you like just to experience that, you can just try to convince an experienced like Java senior developer just to like consider him to like try functional programming. It would be a very hard job. So there is also eliteness to that, but yeah, we'll see how the communities will interact together in future. This is a really interesting story to see how it plays out. Like, but from like just to consider functional programming community, I think it will grow, it will develop, it will be more approachable, more inclusive, and it will be just better from day to day.
Yeah, I do think as well the same. I checked trends on language, and of course Python is winning everything, but and Java is losing the market share each year significantly. Scala is not growing anymore. It was growing for several years, and now it's stagnating a bit, around 1% share of all languages. But Rust is taking the hit with that, and it grows quite rapidly.
Mm-hmm.
And I think at the end of the day, it's not about Java virtual machine or not. It's just about building the systems that are, as you mentioned, time to market will win. And of course, there is some kind of historical background behind why functional programming started the way it started, and that's why it is where it is. But in some years from now, I think because it's really hard to scale CPUs, I think that's the main reason. It will be really hard to scale, the gigahertz amounts, and you have to go to more and more cores, which is easier for companies. The parallel computing will be the main reason why these old systems will have to switch into functional approach, because doing it in object-oriented way, of course, is possible, but it's really painful. I did that, and it was really like I felt like a guy who is a conductor on a railway station that is, putting two trains in the same railway, and then they have to join, and that's kind of how you do how you do parallel computing in object-oriented way. You have to actually make it in a really specific way. So so it becomes really problematic in a bigger approach when you keep doing other things in an object way. So I do believe that there is a path, and of course we as Scalac, we are all in Scala, and we do enjoy other languages. Some of our engineers are also investigating Rust. And then some of them are investigating ReasonML and all that stuff. So we keep open to other languages that are good for our engineers. So we listen. But in the end of the day, I think Zio is also a new kid on the block, right? I talked with you a bit about Zio, and you said that it is interesting. You enjoy, right, writing in it.
Yeah.
But it's not there yet for business in your kind of hindsight, for a serious business, we could say still. Or...
Yeah. Not entirely. I think it depends on like what kind of business you have, like what kind of a team, what kind of like goals you have for your business, like at least short-term goals. So I think long-term Zio is going to be an amazing project, and with all that support, with John de Gaulle's as the leader, with all the open source support it gets, I think it will be an amazing tool. And just it's not one. It doesn't have a stable release yet, right? So it's really early to like pick it up for like enterprise level software. But you can already write some like simple small services with it. So and I know people are doing that. Netflix is doing that, and some other big companies are like using Zio in production, like for some like not super important stuff, right? Because that's how you like test a new technology. That's how you make it like reliable, right?
That's the safe approach you mentioned a few minutes ago, right?
Yeah.
When companies try to introduce new technology, they can either do it full blown, like let's rewrite everything and pray that it works, or try to do some small module in it, then bigger one and bigger and bigger. Right.
So I think it's already a good time for Zio to be used as an experiment, as like a tool for some new internal or like production external but not important project. It's already time. So I wouldn't say that Zio is entirely not for business at this moment. But I would be really, really careful, like going all in on Zio for all of the systems in my company. So yeah, but overall, I would definitely be like, regardless of whether I'm using it or not in production, I'll be having a close look, and I would recommend for anyone interested in functional programming, like to have a close eye on how Zio develops, because it has all the values I mentioned. It strives to be really accessible, inclusive, friendly to all kinds of developers, beginners and like seniors. So, like all sorts of developers can get a lot of benefit from that, because like it's how it's designed. So I think it's really it has really bright future. If nothing goes really awfully wrong, it has really great future.
Thanks. Thank you, Vladimir, for all of the input. Yeah, the Zio is one of the open source projects we also support as Scalac. I need to say that because we have to be honest. So we believe in it, but of course we also have to be honest to the people who might watch this video, is that it is something we will put a bet on, and we think will grow and will become a nice way for engineers to go into functional programming without entering the wizard club. So that's kind of the good thing that we would like to do. We would like to make Scala popular, and making it popular means that people who were not wizards, they can join this club without any huge issues. So that's kind of the future. And when it comes to functional programming, I also think that it's a matter of time. It's a matter of time when people who are now young become senior engineers and then become tech leaders. These young engineers are picking functional programming much more often than the older ones, because they are trained even on universities. Even in Poland, we have faculties, even in Gdańsk, where we are based, where there is functional programming taught already. So they are directly going into Scala. There is no object-oriented path even. So it's really crazy.
I'm so jealous. I would love to have this as my own like university education program. I'm jealous for these people.
Yeah, when I hear about that, it was like, wow, are they crazy or something? You know, it sounds really, even like for university, it sounds really brave. So they picked that path, and I think it's really good, because engineers have to learn that you have to write code that is immutable, it is concise, it is readable, it's working in a multi-thread environment. So you have to write code from the very beginning, thinking about that. It's the era of desktop applications that have one thread is over. So we have to finally teach people about that from the very beginning, and that's
that's right.
Okay, great. Vladimir, thank you very much for the call.